Very good afternoon to all of you. Okay, we are going to continue the second order linear homogeneous differential equation with constant coefficients. Okay, yesterday we have looked at the homogeneous. Homogeneous means the right hand side is equal to 0. In yesterday you have seen that you have said y double prime plus y prime plus here y equal to cannot difficult to write. Yesterday you see sometimes so difficult to write. Forget about it. Okay, we look at this one. Yesterday the right hand side is 0, so there is a homogeneous equations. Now the right hand side no longer 0, it's a function of x or constant value. So this is a non-homogeneous equations. Short form we just call non-homogeneous equation, and we just consider up to the second order. So you see is up to the second derivative, linear because the coefficient the power for each derivative, second derivative, first derivative, and y is actually power 1. Okay, constant coefficient means the coefficient for your second derivative, first derivative, and y here is constant value. Okay, or sometimes d2y dx2 can be written as y double prime. dy dx is y prime, y of course is y, so ay double prime plus by prime plus cy equal to fx. And the general solution for this case, second order non-homogeneous equation is actually given by y. Okay, you want to find the solution for the y is actually yc plus yp. Okay, where the yc is actually the solution for the homogeneous equation they have learned yesterday. Okay, yc actually or stand for the complementary function, is actually solution for the homogeneous equation. And then today we are going to add up this yp, which is called the particular not particular solution, sorry, type. So be particular, this one is integral. Later on I will edit back the slide. Okay, not the particular solution. Particular solution is obtained when you substitute the initial condition into the general solution. So this yp is actually called as the particular integral. Don't know why I cannot write. Pen. Okay, the particular integral. So you have learned yesterday how to find the homogeneous solution, or it's actually the yc part. Now we are going to learn how to find this particular integral in this first hour. Actually we have two methods to find this particular integral. Okay, but what you have we will learn is only the first method, which is called as an undetermined of coefficients. Let me see whether I can erase it. Yeah. So this is particular integral. It's actually the solution for the the right hand side part, which is not equal to 0. Mean the particular integral is actually you want to solve for the right hand side part which is not equal to 0. And then we have two methods, but we will just concentrate on the first method, which is method of undetermined coefficients. it is actually one method to find the particular integral, especially suitable if the fx is in the form of polynomial, exponential functions, cosine or sin function. Not suitable, mean the fx can be polynomial only, exponential function only, cosine or sin function, or combinations. Mean you may have polynomial plus or multiply or divide. With mean combination of these three functions, not stand alone only. However, it is not suitable if fx is in the form of ln x, 1 over x, you have a tangent x, or the arc sin x, and so on. Mean suitable for combination of polynomial, exponential, sin, or cos functions. And then it's actually how to find the yp is actually you choose yp with the same form with your fx and determine its coefficient. That's why it is called undetermined coefficient. For example, your fx is a polynomial of degree n. Mean the right hand side. Yesterday you learned the right hand side fx is equal to 0. Now let's say the right hand side is a polynomial of degree n. Then you are going to choose your yp in the same form. If your fx is polynomial of degree n, then you should choose your yp also polynomial of degree n, but the coefficients we will put it let's say bn minus 1 up to b1 b0, where the coefficient of bn we are going to determine later on. That's why this is so called undetermined coefficient. And then yesterday when you learned the homogeneous solution, you have the if your root is same root, if your characteristic equation you got the same root. Remember yesterday, if you have the same roots, let me see whether I can write some. Remember yesterday, if you have the same root and then your y, this is a yc or homogeneous solution. This not familiar. Remember yesterday you have y equal to e m, same roots, e m x plus b, I said b, you must multiply x, because when you have the same roots, what I said, when you have same roots here, a e m x, and then you cannot say b e m x because they have the same solution, cannot, so you multiply by x. So it's the same thing. You will choose the yp based on the pattern of the fx. If your fx is polynomial, then you choose your yp also polynomial. However, you are going to determine the coefficients for your polynomial later on. And then after your first case, after you choose that pattern, you have to check whether your yp same pattern with your yc. If same later on, mean like here, if you have, let's say, the second case of the homogeneous solution, for the first solution you have a e m x. Actually, second solution, if you demultiply x, you have b e m x. Same. So that what we call clash, you have to multiply by x. So same thing with here. If they have the same solution, it is clash, then you need to multiply by x. Then why x power r? Mean if clash again, you increase the power here, x squared, x cubed, and so on, until no more clash with your yc. The yc actually solution from homogeneous solution yesterday. If second case, if your fx is a exponential, your fx c here, meaning you put c can be 2, 3, 4, 5, any constant value, then you should choose your yp also same pattern, exponent kx. So your yp also you have to choose exponent kx, but you put it unknown parameter, let's say p, and then you are going to determine p later on. and then you have to check whether this yp clash with your yc. Okay, if clash, then you multiply by x and so on. Okay, the third case, if you have the fx is a trigonometric sin or cos, let's say c cos beta x or c sin beta x, then you should choose your yp is p. Okay, you see cos beta x, so p cos beta x plus q sin beta x. If the yp clash with your yc, then multiply by x. And then the fourth case is a polynomial with exponential, multiply with exponential term. Fifth is a polynomial with sin or cos. Number 6 is the polynomial with sin or cos. Number 7 is polynomial exponential sin or cos, and these are their corresponding formula. So we'll go to the example first. We look at the first case, polynomial functions. For example, solve y double prime plus 4y prime minus 2y equal to 2x squared minus 3x plus 6. So this is what we call the right hand side here is your fx. So fx is a polynomial. So the first case, then we'll choose your yp, also polynomial. Fx is polynomial of degree 2. Then you choose your yp, also polynomial of degree 2. But before that, before find your yp, you have to find the yc. To find yc, you will let the right hand side equal to 0. Right hand side equal to 0 means you find the solution of the homogeneous equations. Y double prime plus 4y minus 2y equal to 0. And then in yesterday you have learned how to find the solution for the homogeneous equation. It's actually through the characteristic equation, where you let the second derivative by m squared, y prime by m power 1, y is actually m power 0 or 1. Then you get this characteristic equation. And you may use your scientific calculator, or you may solve it if you cannot factor, or you get complex root, then you solve it using the quadratic formula, which is negative b, where b is a coefficient for a linear term, plus minus square root. This is b squared minus 4, a is 1, c is negative 2. Then you simplify it. 24 is actually 24 here. You have 4 times 6. So and then it becomes 34 times 36. So 34 is 2. And simplify again, you will get negative 2 plus minus 36. Or those who use a MS calculator, you should get 0.4495. And then I want to show you something. No. This is a calculator link that I sent to you, where you can download. Then what is the equation already? We are going to solve it using your scientific calculator. For those who have the MS, I would suggest that you directly chain to this model, which is Casio 570EX. 570EX. Then you may go down to the equations. this model you have can solve the simultaneous equation up to 4 order, okay, 1 order higher than the ES model. Again. Okay, and then for polynomial, you can solve up to degree 4, 1 higher, okay, 1 order higher than the ES model. Now you want to solve the quadratic, which is polynomial of degree 2, type 2. Then you just key in the coefficient for the characteristic equation, which is m squared plus 4m minus 2. Right? Here. You have m squared plus 4m minus 2. So 1. Coefficients 4, negative 2. This one. Okay. So you straight away get is negative 2 plus, okay, you have x1, this is the first root, negative 2, okay, plus 6, you get the second root, negative 2 minus 6. Okay. So first step is what you have learned yesterday. Finds a homogeneous solution, and now we label it as we got the root is actually negative 2 plus minus 6. I change it to floating point. Okay, this is the value. Learned yesterday, because yesterday is only homogeneous solution, so it's straight away using y. Now this is non-homogeneous solution. We have another part of solution which is yp. So we labels, okay, the homogeneous solution using yc. Okay, if you look at my previous word, okay, the notes in the author, I may use a different notation which is yh, where the h there stands for homogeneous, okay, solutions. So you have is actually this is the first case of the homogeneous solution. You have real and different root, real and different roots. So you have a, e, okay, this is your m1, negative 2 plus 6x plus b, exponent, this is a m2x, where the second root is negative 2 minus 6x. So this is what you have learned yesterday. Now the new thing here is how to find your yp. Okay, in my notes in the author, okay, in the word versions, the yp I use a yk, just different notations. So okay, the yh there is actually the yc. So now, okay, how are we going to determine the yp? Using undetermined coefficient, if you look at the fx here, this is polynomial of degree 2. Hence, you will choose the yp also polynomial of degree 2. Mean px squared plus qx plus d. Okay, you can use any symbol, any variable, but don't use a and b, because a and b is a constant, okay, in your homogeneous solution. Okay, you have used a, b, maybe you like to use this is cx squared plus dx plus e also can, but as long as don't use a and b. Okay, may I know you have any question how to choose your yp or not before I proceed?
Yes, how to choose the yp?
Look back the right hand side, the fx. Okay, fx, you have to open back. Yeah. Now this is the fx, polynomial of degree 2.
Okay.
Then you choose your first try, you choose your yp also polynomial of degree 2. but the coefficient we are going to determine later on. Okay?
Okay.
So that's why yp will just be x squared plus qx plus r. And then, okay, you have to check whether this yp clash with, whether this yp is clash with the yc or not. Okay, yc, we have the first case, right, is in exponential term, exponential format. Right, this is our yc. Exponential, okay, term, exponential term. And the yp that we choose based on the right hand side is a polynomial. So polynomial term and exponential term are totally different. Totally different. So it is not clash. You no need to multiply by x. What is that? Sorry. Hold on. Suddenly. So if it is not clash, then you differentiate scale. You differentiate one time because you have a second order differential equation, right? The y, okay, you are going to substitute yp into the y term, and then you have a dy dx. So from the yp, you have to differentiate it one time. So differentiate px squared plus qx plus r. You have 2px plus q. Now remember, you have a second order non-homogeneous equation. So you need to differentiate second time. So you plug in, okay, y double prime p into the second derivative. Okay, this in the first derivative, yp into the y. Okay, this is a ODE that we are going to find the value of y. Hence you plug in here, mean the y double prime, mean the 2p, you are going to plug in here, 2p. So 2px plus q, put it in the y prime. Yp, okay, you substitute the yp into y here. And then we compare the coefficients, okay? We compare the left hand side and right hand side to determine the value of PQR. So that's what we call undetermined coefficient. Okay, is it clear?
Yes, doctor. Clear.
Okay, and then so you let, okay, the next step, just plug in. So this is actually y double prime. This is actually y prime here. Okay, this is actually the yp. Then equal it to the right hand side. The fx is actually 2x squared minus 3x plus 6. And then, okay, you may expand, simplify, or if you don't want to expand, you may collect the same power of term. Mean you can compare the quadratic term left hand side, right hand side, linear term left hand side, right hand side, constant term left hand side, right hand side, like you determine the coefficient for your partial fractions. Then you are going to, okay, know the value of PQR. Once you know the value of PQR, you know the YP. Hence, you take the YC plus YP. That will be the solution for your non-homogeneous equation. Okay, so now this one is actually after expand and simplify. Okay, never mind. Yeah, I redo again. Okay, after you plug in the, this is y double prime and y prime and y, expand, simplify, then we compare the coefficient left hand side, right hand side. So when I put it here, x squared, mean I compare the coefficient of x squared. Left side you have negative 2p, right side you have 2. Then you can obtain your p, which is actually, okay, negative 1. Then it compares the coefficient for x power 1 left side, right side. You have 8p minus 2q. The right hand side is negative 3. And then you plug in p is actually negative 1. Hence you have actually 2q, because p is negative 1, so you have negative 8 plus 3, so negative 5. So your q is negative 5 over 2. Right. Then plug in the p, you should be able to solve for the q here. Then to find the r, you compare the constant term. 2p plus 4q minus 2r equal to 6.
Doctor?
Yes?
Just now, sorry, where do you get the p? One more time?
P.
Uh,
No, this one. Compare the quadratic term x squared, negative 2p, x squared. Compare with the right side, 2x squared.
oh, okay. Thank you.
Okay. So after that, you plug in the PQR value, you obtain your YP. Your P is a coefficient, okay? Remember just now we already assigned your YP. Okay, initially we assigned here. Our YP is actually P x squared plus qx plus r. YP, YP is px squared plus qx plus r. So p is negative 1, so you got negative x squared. Q is negative 5 over 2, so negative 5 over 2x, r is negative 9. So this is your YP. And the general solution for the non-homogeneous equation, you have a YC plus YP. So YC is actually this part. Okay, YC is a solution for homogeneous equation, this part. Yeah, this one. This is homogeneous solution. So the new thing for today is actually your YP. We find the YP using undetermined of coefficient. Okay, so any questions before we look at the clash case? Okay, if you no question, we proceed to the second case. The exponential term. Okay, the second case, now we have the right hand side, we have exponent x. So this is a second case of your non-homogeneous equations. So first step, you will solve the homogeneous equation, means let the right hand side equal to 0. In the first step, homogeneous equation means you let the right hand side here 0. Then to solve your homogeneous equation, you will find the characteristic equation where you let y double prime as a m squared, y prime as your m, y is m power 0. Then you solve your characteristic equation for your m. So in this case also we get a real and different root. So your YC is a homogeneous solution. It's actually A exponent x plus B exponent 4x. Okay, you may swap A and B, doesn't matter. Okay, this is also like yesterday, solution of homogeneous equations. Now the new thing, how to find the YP if your fx is exponent x. Okay. So if the fx is exponent x, we'll choose the yp also exponent x. Here if exponent 1x, then you choose your yp p exponent x. If you don't like p, you want to use capital C also can. But don't use a and b, because a and b already used. Okay? And then I said, after you choose a yp, you have to check whether the yp clash with your yc or not. So you see p exponent x and a exponent x is actually same form, same pattern. Don't say this is a, this is p, different. We said same form, same expression. We are not going to determine their coefficient. If you want the same coefficient, of course they won't be the same. But we want the if they are the same term, then we said clash. If clash, then you need to multiply the initial guess of the yp by x. Right here. After you multiply by x, px exponent x. Not the same, because this is only constant time exponent x. But the first try, if you put p exponent x, this will be clash with this term. So cannot. So if cannot, you need to multiply by x. Okay, this one. Okay, the clashing one. Is it clear?
Clear, Doctor.
Clear.
Yeah, because undetermined coefficient, if you choose the wrong yp, then you may correct up to your homogeneous solution only. The rest will be gone. So make sure you understand how to choose yp. Okay. And then if this one no more clash, you can and you see your ODE is second derivative. So mean the yp that you choose, you substitute into y here. Mean y substitute by yp. So y prime, that's why from yp you need to differentiate one time. Then differentiate second time. So plug in everything, compare left side, right side to determine the coefficient of p. After you obtain the p, then you get the yp, which is what we call particular integral. And then add up your yc and yp, that will be the general solution for your non-homogeneous equation. Okay? So this is a yp. Now you need to find first derivative. So can you differentiate this one to get the first y prime p? Yeah, this is x, and then p is a constant, p exponent x. So you're in the form of uv, u multiply v. So you need to use a product rule for your differentiation. Okay, this is after applying the product rule, where your u is mean you differentiate the for this case I think I differentiate u first and then v maintain. That's why I got the px exponent x. Later one, the second term, this is v u prime. Maintain the v, differentiate the u. Okay, anyone not clear how to use a product rule to do differentiation? Okay, if no, mean you understand how you do the differentiation. Okay, I will show one more time. Mean if you I don't know how to write in the use the tablet to write on PowerPoint. This is using mouse, difficult to write. ddx uv, you have u v prime plus v u prime. So using uv prime plus vu prime. So this one, the second term is actually my vu prime. The first term is actually my v prime. And then I factor out the p exponent x. So 1 plus x. Then you need to differentiate one more time. Again, this is the u. This is the v. Using product rule again to get your second derivative. Okay. So again, what I did is actually this is u, and then v prime. You differentiate 1 is 0, differentiate x is 1. That's why this result is actually u v prime. Okay. Later on, you have your u. This is a u. Differentiate u v prime. Later on, v. Okay. Second result here is actually this is a v, v, and then differentiate the u, still get back p e x. Then collecting the same term, which is p exponent x, you get this one. Then later on, substitute your y double prime p in the y double prime here, y prime p into y prime, your y p into y. To compare or to determine the coefficient for your p. Okay, before I proceed, who don't know how to differentiate using product rule? Is it okay? So teaching in the synchronized online class is talking to the monitor. Okay, after I think maybe finish chapter 2 or a little bit of chapter 3, later on, I will just put out the last semester video because it's also same thing. And I talking, no response. So better use back the pre-record video. So you plug in the yp, y prime p, y double prime p into the differential equation, to determine, I think only p. This one is only p, So this is after you plug in, this is a y double prime, this one is a y prime, this is a y. And then, you may simplify, or if you don't want to simplify, I will just compare directly. You may simplify, and then you can, you expand, simplify. Or sometimes I'm lazy to simplify, I will directly compare. I see the right hand side, I have the exponential term, exponent x. So I'm going to compare the coefficient of exponent x, left side, right side. So the right hand side, I have 8. Left side, I want the only exponent, exponent x term. So will be this one, 2p, because 2p exponent x. This one is not. This one is actually x times exponent x. So 2p. The coefficient is 2p. Another one is this one, negative 5p exponent x. And then this one, this is not, this is 4px. So that's why the exponent x term, left side you have 2p minus 5p equal to 8. Then you can solve for your p, which is actually negative 8 over 3. So that's why your yp is actually negative 8 over 3 x exponent x. Then the general solution will be your yc plus yp. where the YC actually you have A exponent x plus B exponent 4x add up with your YP from here. Okay, any questions? This is for exponential term, but however your initial try of YP is clash, is clash with the right hand side. Mean initially you choose YP is P exponent x, clash with this term, so you have to multiply by x.
Doctor,
Yes.
I don't really catch about the how you get the P equals to negative 8/3.
Okay, this one is, okay, this line, do you get it? Y double prime from
Yeah,
the
Y
previous
double.
slide.
Okay, I understand.
This one you get.
Yeah, I get.
Okay, if you cannot see what I compare like this, then you may expand, simplify. Okay, if I compare like this, you cannot understand. You expand your left side. My left side. Okay. Wait, hold on. Mean if I compare like this, you cannot see. You just expand the left hand side of here. So you got what? Let me try to write. You have this one cannot write in the my tablet cannot write in PowerPoint. So you expand this one, you got 2 exponent 2p, expand this term 2p exponent x plus p x exponent x here. In this one, you expand it 2p exponent x plus px exponent x, and then expand this one.
Oh, okay.
You expand one by one, simplify. Okay, so negative 5p exponent x plus minus 5px minus 5p x exponent x. Okay, the last term plus 4px exponent this is exponent x, not exponent negative x, this is exponent x, equal to 8 exponent x. Okay, my step is I'm lazy to expand it. I just observe and extract it out. If you cannot see what I do here, you may expand, simplify. So 2p, and then you can collect the same term, exponent x term. So here I got 2p minus 5p.
Negative 3p.
Right?
Exponent x.
Mean for exponent, okay, the exponent x term, left side, you have here 2p. This one minus 5p. Okay, and this one is a x exponent x. Okay, x exponent x. Okay, you notice this one, this is 1 px exponent x plus 4px exponent x minus, so 0. So you only left 8 exponent x. And then, okay, you cancel exponent x left side, right side there. So you get here 2p minus 5p equal to 8.
Oh, okay. Understand now.
This is actually like what you did for when you find a partial fraction, also the same thing, comparing the same power of term.
Yeah.
Because if you do it several times, you're lazy to expand. You just extract the same power of term. I mean, for here, I just extracting. So, but if you cannot see, you may expand, simplify, then you compare.
Okay.
So you arrive at this step.
Understand.
Okay, and then we move to the third case, the trigonometric mean sin or cos term. So the third example you have here, the right hand side is sin 2x. So this is the third case of that table of that 7 cases. If you got sin 2x, then you should choose your yp, let's say p sin 2x plus q sin 2x, initial try. And then you should just check whether your yp clash with yc. If clash, then multiply by x. If not, you're safe to use, and you can differentiate 1 time, 2 time, plug in into your ODE. So before that, you have to solve the solution for homogeneous equation. Mean let the right hand side equal to 0. Mean first step, you have to let the right hand side equal to 0. Get the solution characteristic equation, which is m squared plus 4. Y is m power 0. So m squared plus 4 equal to 0. So you have now, this is a complex roots. So you have in this case your alpha is 0 because you got 0 plus minus 2i, beta is 2. So your yc is actually because you have alpha 0, so e alpha e0 e exponent 0x, which is 1. So you just have a cos, beta is 2. So a cos 2x plus b sin 2x. Okay, for the homogeneous solution, the third solution here, complex root. Who's still not clear how to get, especially this one is a complex root?
No, doctor.
Okay.
No, doctor.
All okay.
Clear, doctor.
Mean you look at the solution, 3 cases for homogeneous solution. This is a third case where you plug in alpha 0, beta is 2 into that table. So you should get a cos 2x plus b sin 2x. Okay, after that you choose a yp based on the fx term. You have sin 2x, that's why your yp will be here. If you don't like PQ, you may put this is C, this is D, also can. Okay, if you put, let's say this is P sin 2x, this is Q cos 2x, doesn't matter. But only my marking, the marking scheme will be, mean you have to tally it. And then after you choose it, you have to check whether this is clash with your YC. Okay, you see, you have here cos 2x, sin 2x, your YC also same term. So this is what we call clash.
Doctor, so it means if you just try and error, is it?
Not try, first try is choose based on fx term. Fx is sin 2x, then yp must be p, okay, p sin, you want p cos 2x plus q sin 2x. First try is actually chosen based on the fx term. After you choose, have to check whether same term with yc. If same term, then multiply by x.
Okay.
If not clash, no need to multiply. Okay, multiply the whole thing by x. If clash, if not clash, no need. Okay, for example, let's say your right hand side, okay, this is let's say the right hand side is only like here, 3 sin 1x. Then you should choose your yp, p cos 1x, q sin 1x. Then you check your yp and yc. Is it same term or not? What I mean same term, if here cos 1x, if p here is cos 1x, sin 1x, then yc must be also cos 1x, sin 1x. However, this is 2x. 2, right? Different. Even though they are sin and cos, their coefficient must be same.
Understand.
So if the right hand side is sin 1x term, then your yp not clash, then you just use this one. No need to multiply by x. Is it clear?
Yes, doctor.
Clear.
Yeah, okay. However, okay, we purposely choose this one, the clash one. So we purposely design this one is a clash. You have here cos, this is cos 2x sin 2x, same, exactly same term with yc, clash. So you have to multiply by x. After you multiply by x, it's totally not clash because you have x times cos 2x. Here is only cos, only sin, so totally no clash. Okay, if no more clash, then you differentiate 1 time, 2 time. Okay, because 2 time you need to put into the y double prime. Okay, and the yp you put into the y. So,
Doctor,
yes.
sorry, but I don't understand why we need to multiple with x for the second try.
Yeah, because I said, okay, for undetermined or coefficient, first try, you choose your yp based on your fx, must be same term. If here sin 2x, it must be p cos 2x plus q sin 2x. And then you check, okay, whether your yp same term, exactly same. The cos 2x and cos 2x same, sin 2x and sin 2x same. Don't look at this is p and this is a. We don't care about the coefficient because coefficient later on we are going to determine, but we cannot have the same term.
Okay.
Cos 2x same, sin 2x same. So if same, the whole thing bracket multiply by x.
Okay, Doctor. Okay.
Okay, and then just now your yp that you choose, just now the yp that you choose is actually x p cos 2x, p cos 2x plus q sin 2x. And then again you need to differentiate using product rule. Okay, where the x is actually the u, your v is actually, okay, this one, p cos 2x plus q sin 2x. So your first derivative means y prime p. Okay, my solution here is actually this is u, this is a v prime. Mean u, maintain your u, differentiate the v. So you differentiate p cos 2x, differentiate cos, you get negative, negative 2 sin 2x. That's why you have negative 2p sin 2x. Okay, differentiate q sin 2x, you got positive 2q cos 2x. So plus, the second term here, this is actually v u prime. Because differentiate the u, you have 1. So the result here, this is u v prime plus v u prime is 1. So this is a first derivative. And then differentiate one more time to get your second derivative. So for your second derivative here, the first term, again you need to use product rule. This is u, this is the v. So you have the result u, this is actually v prime. Mean u, which is the x, v prime. Again, differentiate sin 2x, you got 2 times cos 2x, 2 times negative 2p, so negative 4p cos 2x. Okay, differentiate cos 2x, you got negative 2 sin 2x, so negative 2 times 2q, negative 4q. So plus, this result is actually v here, u prime is 1. And then the third result is actually from here. Differentiate p cos 2x, you have negative 2p sin 2x. Differentiate q sin 2x, you got 2q cos 2x. So plug in your y double prime. Oh, before that you may simplify, then you plug in into that ODE. Okay, after that, this one is you simplify the term. How to simplify? You're collecting here. This term, negative 2p sin 2x. And this one. So total negative 4p sin 2x. 2q cos 2x, 2q cos 2x, so 4q cos 2x. Then plug in your yp. We don't have this term, we have only second derivative. So okay, the first line, this is your y double prime. Okay, this is actually your yp. So same thing here. Okay, if you cannot extract directly, you may expand, simplify, and then you compare the sin 2x term and cos 2x term. Then you should able to get the p and q. Okay, however here, I just directly extracting. If you cannot, you may expand it. In here, I just directly compare, because right hand side I have a sin 2x, the coefficient is 3. Left hand side, okay, so this is a sin 2x term, negative 4q times x. Oh, I want sin 2x term only, so this is not. Let me erase it. Okay. Okay, I want only sin 2x. Okay, this term is multiplied by x, so I don't want. I just want the sin 2x term here, negative 4p. Okay, this term also cannot. This is actually time with x. So for sin 2x term, I got negative 4p equal to 3. Hence, p is negative 3 over 4. Later on, okay, I compare the cos 2x. Right hand side is 0. Left hand side, which is 4q. Okay, if I expand, actually, okay, other term actually cancel out. Here, negative 4x p cos 2x. Okay, this term and this term cancel each other. Okay, this negative 4qx sin 2x. Okay, this one and this one cancel each other. That's why after simplify, you get only negative 4p sin 2x plus 4q cos 2x equal to 3 sin 2x. Then compare the sin 2x coefficient. You have negative 4p equal to 3, 4q equal to 0, hence q equal to 0. So plug in the p. Okay. Initially, just now we chose the yp is actually because clash, that's why you multiply by x. Okay, you have p cos 2x just now. P cos 2x plus q sin 2x. And then q0. That's why you have p is negative 3 over 4. That's why your yp is negative 3 over 4 x cos 2x. Then you add up your yc and yp. Where the yc, you have a cos 2x plus b sin 2x. Where the yp is negative 3 over 4 x cos 2x. So this is a general solution. Okay, if you want particular solution, they must provide you two initial conditions. To get particular solution, you must substitute your initial condition into the general solution. Not substitute into your yc. Must substitute into general solution. Okay. So, any question before you can try your tutorial?
Doctor, can I see the product rule slide for a while?
Which one already? Product rule? Which product rule?
That one, yeah.
This one, is it?
Yeah.
Okay, I will suggest you write down u. If you cannot differentiate one line, write down u is x, and then your u prime is 1. Then v is actually, write down your v. V is actually your p cos 2x. Yeah. This one in PowerPoint I cannot use my tablet, so this is using mouse. Very difficult to write. So your v prime here, differentiate p cos 2x, you got negative 2p sin 2x. Okay, and then plus, you got plus, differentiate q sin 2x, so you got 2q cos 2x. So the product rule, the result, you have u v prime here, u v prime plus v u prime here. This is v u prime. Is it clear? But I'm sorry, the writing because I don't know.
Yes, okay.
In the tablet, in the PowerPoint, the tablet not functions. When I write, sometimes can, sometimes cannot. So against for y double prime, you need to write this is u, this is v. You do it okay beside. If you cannot do in one line, then you have to do like this. So you have to polish back your differentiation rule, especially the product rule. Because to answer the undetermined coefficient, you need the differentiation of using product rules. Luckily, the second method, variational parameter, is not included. If not, you have to polish back your integration scale techniques. Okay, so any more question?
Doctor,
Yes.
the yp double prime. So
yp double prime, because you got second order differential
yes,
equation.
yes. Wait,
So you need to differentiate 2 times. Mean the y double prime, yp double prime will substitute into your second derivative of your ODE.
yes, wait.
Ah.
So the solution is also like using the product rule, right?
Yeah, this one because to get y double prime p, you need to differentiate here. You need to differentiate y prime p. Mean you differentiate y prime p, you get y double prime p. And then your y prime p, the first term you have u. This is v. So use back against your product rule. Let me see whether I can write properly.
So means you differentiate 2 times, is it using product rule?
Not differentiate 2 times, you use product rule. For differentiation, if you have the product form, then you use product rule.
So for the double prime, you have to take the values from y, the first prime.
Yeah. You
Okay,
differentiate
okay.
second time. You ddx y prime p, you get y double prime p. Product rule, when your differentiation, you have the product form.
Oh, okay, fine.
Means
Paham.
here you ddx in here I cannot write in PowerPoint. I don't know why I cannot write. Hold on. You have, okay, I start from your YP. So to write, insert also need to practice. Oh. Okay, I choose a YP. Just now the YP that chosen is actually you have got x
P cos 2x.
cos 2x. Right in the table also difficult to adjust the position. Plus q. This is
Doctor, sorry.
yes.
Your voice not clear.
Huh?
Your voice not clear tadi.
The yp x cos 2x plus q sin 2x. Here, just want to show how you do the product rule, but I said difficulty because here writing in the using tablet also you have to adjust the position. So this one to get y prime p is actually you what? When you ddx, yeah. When you ddx your yp, right? And then you notice that this one you have product form. Product form u v. To find y, when you ddx yp is actually you get y prime p, y prime p. And then to differentiate here, you have here product form. Because u is function of x, v also function of x. Then you need to do your differentiation using product rule, where u is actually x, and then v is actually p u cos 2x plus q sin 2x. You got limited place to write. So u prime is you du dx, you have 1, and then your v prime is actually p is constant. You differentiate cos 2x, p cos 2x. So cos 2x you got negative sin 2x. P cos 2x plus q sin 2x. So differentiate sin is actually positive cos. So you got 2q cos 2x. Limited place. Better write in where? Go on, find word. But writing in word also, yesterday until one page cannot go down. Okay. Okay. Rewrite again. Where is it already? Yp equal to, you have, this is x, and then p cos 2x plus q sin 2x. To find yp, you use a product rule where the u is x, u prime will be 1, v is your p cos 2x plus q sin 2x. So your v prime, meaning differentiate p cos 2x, negative 2p sin 2x, plus 2q cos 2x. So your y prime p, mean you differentiate your yp using product rule, where you have the form uv. You get uv prime, which is actually x times negative 2p sin 2x plus 2q cos 2x, and then plus v u prime, which is actually p cos 2x plus q sin 2x. And then to find your y double prime p, mean to find y double prime p, you notice that this one, this is actually your u. Again, okay, the bracket here, this is a v, but this one no need uv because this is only not in the product form. So to find the y double prime p, the first term you must apply the product rule again. So that's why mean to find y double prime p, you must ddx your y prime p, then you get y double prime p. Okay, and then okay, the second, when you apply your product rule, one more time. Let me go down a bit. Again, you have u is actually your x, and then your v is actually negative 2p sin 2x plus 2q cos 2x. So your u prime will be 1, v prime will be, okay, differentiates negative 2p sin 2x. You have negative 4p cos 2x. Sorry, this one. Differentiates your 2q cos 2x. You get negative. You get, okay, negative. You get negative 4q
Sin 2x.
Yes. Okay, this is for the first term. Second term, differentiate p cos 2x. You can no need product rule. This one you get negative 2p sin 2x. Differentiate q sin 2x, you got 2q cos 2x. So that's why your y double prime p, let me change other color. That's why, where's my pointer? That's why your y double prime p, okay, which is x negative 4p cos 2x minus 4q sin 2x, okay, plus vu prime, which is actually you have here negative 2p sin 2x plus 2q cos 2x. Okay, this for first term only. Mean to differentiate first term, apply the red color, the product rule. Then differentiate p cos 2x. Okay, differentiate p cos 2x, you got negative 2p sin 2x. Okay, differentiate the last term here, q sin 2x. Okay, differentiate sin positive. So positive 2q cos 2x. Then you simplify your y double prime. Okay, when you simplify, this term, this one and this one, okay, this term and this term combined same. So that's why your y double prime p so your y double prime p is actually, you have got x negative 4p cos 2x minus 4q sin 2x. So total is negative 4p sin 2x plus 4q cos 2x, which is this one. This one, which is here. Okay, still any question?
Okay, doctor, understood.
Mean if you cannot do one shot like what I did, you have to write down your u, v, and then u prime, v prime. Okay, and if you do it several times, you may do your differentiation in one shot like what I did here. Mean I will look at this is u, then this is my v prime, and then my v u prime. Then I differentiate this one. But if you cannot just do like what just now, write down u, v, find your u prime, v prime.